Guys, this is Arv here and I'm back with my new video. Today we're going to attempt to solve a few problems on power and power related questions. And let's begin with the first one. These are easy problems. I think the first one's easy. The second one gets slightly harder. You might have to use calculus, but it's very easy. It's extremely easy. All of you can understand for sure. Even people who are not in calculus can understand that problem. It's pretty easy. All right, let's begin. Okay, so let's start with the first question. Question number one. An object with mass m moves horizontally with increasing speed from 0 to some certain velocity v in some certain time, in a time t. The power necessary to accelerate the object during this time period is. So there's an object like this, and this is an object here, and it moves some certain, so velocity at this point is 0, v is equal to 0, and it moves. The distance is this way, and it moves and it reaches here. How much power is needed to bring it here within some time? That's basically the question. Okay, so let's move to my whiteboard and let's solve this problem. Hey guys, I'm back here again, and today we're going to talk about power. Okay, so I read the question to you guys, and now we're going to solve it. Okay, so basically what the question is saying that is, they're saying that there's a box with zero velocity at the beginning, wants to move some certain distance at some certain velocity in some certain time. We have to find the time it takes for it to reach here, which is some certain distance with some certain velocity. So this is the distance. It reaches a velocity of equal to v final. Okay, and there has been some time elapsed in the middle. There's some certain amount of time that is elapsed within the distance. So how do we find the power needed for it to come this much distance and with this much velocity and this much time? Okay, so let's start with the beginning. What is power? Power is equal to change in energy over change in time, which is also equal to change in work over change in time. There's another formula. Change in work over change in time. But for this equation, for this problem, we're going to use change in energy over change in time. Okay, so as the box, and this is the whole system. This is the whole system. There's no outside thing that's been taken into consideration. There's no friction, there's nothing. This is the only thing taken into consideration. So, what kind of energy has been used? It's moving. So it has kinetic energy. And what is kinetic energy? Energy associated with the motion of an object. So what is the formula for kinetic energy? Kinetic energy is equal to half mv squared. Okay, where m is the mass and v is the velocity. Okay, now they want to know how much energy is basically done. Okay, so how to find the power? So power is equal to change in energy. Change in energy is basically energy of the final minus energy of the initial. Okay, so let's do this. Okay, so energy of final, so that's ek final minus ek initial. The reason we are taking only kinetic energy into consideration is that it's not changing its height from the ground. It does not have a spring to have a spring force of spring energy. The only energy associated with this object is the kinetic energy because it's moving over change in time. So what is the formula? So basically E final we know is half mv squared minus, what is initial? We have the mass and the velocity is 0. So when you multiply half into mass into 0, is basically 0 because there's no velocity. The box is still at the initial point. But when after some time it starts moving like this. That's when it gains the velocity. But at the beginning it's 0. The velocity is 0. So there's no kinetic energy because the box is still. So there's no kinetic energy, which is equal to 0 over t. Change in time is basically t final, which is there's some point in t, there's some t, minus the initial, which is 0t. So t minus 0 is t. So that's how we got t. You don't, change in time is basically final time minus initial time. There's no initial time because at that point it was 0, and now there's some certain t because it took some time to reach there. So what is the formula basically? Half mv squared over t, which basically equals mv squared over 2t. That's the answer. That's the question. There's one option saying that mv squared over 2t, and that's the answer. This is the answer to this question. Alright, so this is the first problem. Let's get back to the second problem. Get back to the next question, okay? This question requires a little bit of calculus, but all of you can understand it. If you're not in calculus, you can still understand this problem, okay? So let's begin the problem. Okay, so a horizontal oriented rope, which is this basically rope, this rope is the rope, okay? This is the rope, is used to pull a box of mass m, this is the box, across this rough surface of a floor. So basically rough surface indicates that there is force of friction. Sorry, pardon my bad handwriting, it's force of friction. Okay, at a constant velocity. What is a constant velocity? State that there's no acceleration. If the coefficient of kinetic friction between the floor and the box is mu, there is some coefficient of friction, okay? The power applied by the rope is what? So they're basically asking for the power applied by the rope to pull the box is what? Okay, so let's solve this problem and let's get back to my whiteboard. Hey guys, so let's solve the next problem, okay? The next problem, so this is how it starts. There's a box of mass m which is pulled by a rope. The rope is pulled at some certain velocity, but the velocity is constant. What does a constant velocity say? A constant velocity basically states v is equal to no constant v velocity is equal to no acceleration. No acceleration. That's basically what constant velocity states. And it's saying that it's been pulled by a rope on a rough surface. A rough surface basically indicates that there's a force of friction in the opposite direction. Force of friction. And they have also said that there is a mu of friction. They haven't given us the value because they don't want us to find the value. It's basically just find the equation. Okay? So they're basically asking with this whole thing, how much power by the rope is needed to pull the box. Okay? Basically. So let's begin. Let's start with the formula power. Power is equal to work over time. Change in work over change in time. Now, take the derivative of work. What is work? Work is basically F times, times F times D over T. Now, when you take the change, it's basically the slope, the change. There's some change in that. So basically what it is so F times dx by dt. Okay? Because you can take this dx by dt, the change in distance over change in time. So what does it basically state? F dx is basically what? The velocity, the change in position. So F over change in time. So what is position over time? What is x over t? Position, change in position over change in time. That's basically velocity. So is equal to velocity. Power is equal to Fv. Okay? Now we're given the V. How do you figure out the F? How do you figure out the F? Let's go with that. So let's do the sum of forces equation. Okay, sum of forces is equal to the force applied by the rope. So I'll call that F rope minus, because force of friction is acting the opposite direction, is equal to minus force of friction, which I'll call FFR, force of friction, is equal to mass times acceleration. Okay. Now I gave you some important piece of information. It's a constant velocity. That means no acceleration. That means the acceleration is 0. So E of F, sum of forces, is equal to F rope minus F force of friction, which is equal to mass times 0, which basically equals to This basically equals to 0. So basically what you can state is F rope is equal to, if you move this to this side, because this is 0, is equal to FR. Okay? So this is the equation. Now what's the next step? What you have to do is now you have to find force of friction. What is force of friction? Force of friction, the formula for force of friction is basically equal to mu times Fn. Force of normal, the force exerted by the ground floor on top of the box. This is force of normal and this is force of mg. Fg, which is also equal to mg. This is gravity. Force of gravity. Now, since the box is not accelerating up or down, mg is equal to Fn. And mg is a better way of saying it because we have the mass. They're saying that there is some certain mass. They've not mentioned it, but they've given it by a letter. And we know the g value is 9.8 meters per second squared. So we can find that. So we can say that Fr is equal to mu times mg because Fn is equal to mg. Now, going by the formula, we found that the sum of forces is equal to this. Correct? F rope is equal to Ffr. So we can say P is equal to sum of forces, which is basically this mu mg and times P. This is the power needed by the rope to overcome the force of friction and bring it to some certain velocity. This is the formula. This is the thing. Alright? This is your answer to this question. And make sure to comment, like, subscribe, and just enjoy physics. Alright, I'll see you soon in my next video on impulse.